Okay, the next injector that I'm going to show you how to assemble and test is what's called a Pintle style injector. These injectors were used for pre-combustion chamber engines in which they didn't have enough compression to create the heat to ignite the fuel. So they would use a glow plug. Well, this injector, what it is that it has a needle valve, which mostly all of them do. It has a body for the nozzle to sit in. It's called a nozzle, and the needle valve goes in it. So easy peasy. The fuel comes in here, and these three holes are drilled, and they come and meet up underneath this area. Now, a way to distinguish a Pintle style injector is that it has a flat bottom compared to other injectors, and I'll show you in a minute. So this needle valve goes, this needle goes inside here, and the seat is inside here. That's what makes a needle and seat assembly right here.
Can I see the other side of it? There we go.
So it sits right there. And one of the tests is to, if it's clean, is to allow it just to sit by itself like that at a 45-degree angle. So I tell the students that think of it as this is the moat that you'll find in castles, that the fuel comes in here, goes through these holes, and creates pressure underneath the needle valve, and it will push it up because it will be pushing up against this area, this chamfered area here. So we assemble that, place it right there, and we're going to get the needle valve now and put it onto the body. The body has three holes also that it's going to feed the oil pressure, the fuel pressure, inside that machined area to create the pressure. And on this one, it's not that important to line it up because of the fact that it only has one hole and it's only going to spray in one direction. So we get the nut. This is the nut that will go on top of here, and it will hold the needle and the holder in one place.
That's like a special nut.
Yeah, it's a 12-point. I don't know if you noticed that, but you cannot use a 3/4 open end to try to get in there. Impossible. So, seeing how we have a open end box wrench, it's usually a 12-point. You put it in there and it fits perfectly. Okay? So, we won't tighten it up yet because I don't want to put too much pressure on the spindle. Now we turn it around. We're going to get, this is the spindle. Now remember, if you remember on the pencil injector, it was a small little piece. Well, this is the same thing, except the shaft is longer because the body is longer. So we're going to put it in there, make sure that it falls. You can feel it hitting the top of the needle valve. So now we know, because sometimes they'll cock, they'll hit the edge and it will stay cocked to the side, then it won't open. So now we'll put the spring, same as the other one. We'll get the nut, and we'll put it in there. We'll start cranking it down until we feel a little resistance from the spring being compressed. And there it is. Now we can make sure that we tighten this up. And now I know that this is hitting down already. The only thing is with hydraulics, electricity, and anything else that flows, it's gonna find the closest way out of there. It doesn't want to go through to do the job. So what I teach the students is to, when you don't have a vise to crimp these on or tighten them up on, use leverage. And what I do is I have them hit down while twisting the body opposite. So you'll get a counter effect like this. And so I go like this, and I tighten it up, and then you know you have a really tight fit. It won't come off. Okay, that's just a little trick for our purpose here at the class. It's faster than going to the vise and putting it over there, and sometimes they squeeze here too tight, and what it will do is it will warp the threads inside here, and then it's very difficult to put this nut on and drive it all the way down. So keep that in mind. So now we'll come over here to the pop tester. We'll come over here, put it back on. Basically from here it's the same procedure as the other one. This is an 11/16 nut there. Bring it up like so. So tightness is very important when it comes to injectors, because again, they will choose, the fuel will choose the quickest way out of there. Just like in hydraulics, just like in, well, this is hydraulics actually. So this injector here normally is about between 2 and 2,500 pounds per square inch to open the nozzle, so, or the needle valve. So the same applies here. This nut, when you tighten it up, it's going to put pressure on the spring, and at the same time the fuel is going to be running inside here. Again, pipe, pump, line, and nozzle. It's going to run in here, hit the pressure chamber of the needle valve, except that on this particular injector, since it's only one pin, that's why it's called a Pintle, it's going to push on that chamfered area, like the V, and so it goes through those 3 holes down to underneath and hits underneath here to that V. And so now, let's say I'm going to set 2,500 on this one. So right now we are very low, right? So we'll tighten it up. I'll go about 1.5 turns. My goodness. Almost right on it.
It's just that good.
Even a blind squirrel finds an acorn once in a while. But that's actually what you do on this one. These have a jam nut that goes up here. Once they set the nozzle opening pressure at a fuel rebuilding shop or an injector rebuilding shop, they'll put a jam nut here so that this does not rotate, and then a cap goes on here. And that's pretty much it for this injector.